Okay, I'm just going to do a quick review for those of you who either have not finished your logarithm quiz or just need a refresher on logarithms. So the first page of your quiz that you ended up taking, if you recall, was just going back and forth between log form and exponential form. So if you notice, my log form has the actual word log, and all I'm doing each time, here's log form, here's my 2, I'm literally doing a loop-de-loop. So I'll say 2, that's the first number, the base is what I go first, raised to the third equals 8, and that's the exponential form of it. Okay, so 2 to the third equals 8. So the numbers you would touch are the order. So now if I go the other way, if I have exponential form, this is 5 to the second equals 25. Well, to do log form, again, you're doing loop-de-loop. Here's the 5 raised to the 25, or I'm sorry, log base 5 of 25 equals 2. When you have the word log, your exponent is always your answer. Okay, so 5 to the 20, log 5, 25 equals 2. So the order you would write it in, whether it be putting it in exponential or not, it's always just that loop-de-loop. So that's the first part you have to have down. Then we did some problems. Now, I'm going to go a little out of order here. So I'm going to start with the 3 to the x equals 81. When you have things in exponent form, your big goal is to get them to have the same base. So this has a base of 3. I want 81 to have a base of 3. So I'm going to say 3 to the x, and I'm literally going to look at powers of 3 and see if there's any powers of 3 that equal 81. So I'll go 3, and I can take my calculator even, and I can just go, I can say, what's 3 to the first, 3 to the second, 3 to the third, and if you notice, 3 to the fourth is 81. So once you have matching bases, you cancel the bases out, x equals 4. Okay, now if you have a fraction and you're trying to get rid of that fraction, we get rid of the fraction using a negative exponent, but there's already an x there, so this is 3 to the negative 1x equals 81. Well, we already said in the previous one that 81 is 3 to the fourth. Now that we have matching bases, we can cancel out, and I have negative 1x equals 4. Divide by negative 1. That gives you x equals negative 4. Okay. Now, I'm gonna be going a little out of order here. Let's go with this one first. If I have the same base log on both sides, equals log 3, once I have it down to 1 log on each side and it's the same base, I can what I call delog it. Then you're left with an algebra problem. X plus 6 equals negative 4x plus 31. Now you're solving. You can add 4x to both sides. Remember, you get your x's together. That's 5x plus 6 equals 31. Subtract 6 on either side. Now I'm left with 5x equals 25. And when I divide both sides by 5, I end up with x equals 5. Okay? All right. How about one that still they all have logs, but I can't delog it. I can't delog it till I get this left side down to just 1 log. So the plus sign here indicates in the property of logarithms that we're going to multiply. So we're going to multiply the 3 and the 5x. So it's going to be log base 7 of 15x. I multiplied those. Okay, equals log base 7 of 30. Well, now we have 1 log on each side with the same base. I can delog it, leaving me with 15x equals 30. Divide by 15, and we get x equals 2. All right. Now, what about those ones that do not have a log on the other side? For example, I have this one here that we have log 5, and it equals 2. There's no log on this side. So this is where first we're going to get this down to 1 log. So this is log base 5. And with the minus, instead of multiply, it's a divide. So to divide, it's going to be 5x plus 1 over x. Now it still equals that too. So what do we do? If I don't have another log, I loop-de-loop it. So I go 5 to the second equals this piece. So we're going to just continue with this. So it'll be 5 to the second equals 5x plus 1 over x. Well, then you figure out what 5 squared is, which in this case is 25. Then, when you have x's on both sides, you're just going to cross multiply. So this is 25x is equal to 5x plus 1. Subtract 5x from both sides. I get 20x equals positive 1. I'm going to divide by 20. And sometimes you will notice we get just a fraction. If you want to turn it to a decimal, just round to 2 decimal places and that would be acceptable. Okay. Those are some examples for you. That should help you with your quiz. I wanted to talk about one last one, and that's the top here, this one. If you notice what's different about this one is that there's a number in front of log. So that number in front actually counts as an exponent for the 7. So this will be log base 4 of 7 squared plus log base 4 of 3 squared equals log base 5 of 3x. Then I would go ahead and I would put this plus tells me to multiply. Well, 49 is 7 squared and 9 is 3 squared. So I've got now 49 times 9 log base 4 of 49 times 9 equals log base, oh, I see I put a 5. It meant to keep it as a 4. Let's leave that as a 4. Log base 4 of 3x. Well, I can de-log it now that they have the same log. 49 times 9 is 441. And then that equals 3x. I divide by 3. And in this case, x will equal 147. And that's all you have to do. Now, sometimes you have to think a little, but if there's logs on both sides, you're looking to get down to 1 log each. If there's not log on both sides, you're looking to do the loop-de-loop and simplify. Good luck.